In the last lesson, we started building our fetchTitles function and created the URL containing trending movies. In this lesson, we'll complete the function by handling the API response and parsing the JSON data. First, let's fix a sneaky mistake in our URL. We forgot a / after trending. Without the slash, trending movie would be combined and the URL won't work. To help us debug when we run the code, add print fetchTitles URL. This will print the URL in our console and allow us to inspect it. We do get a warning because fetchTitle URL is an optional. To safely unwrap it and handle potential failures, we need to update our network errors enum. Open the errors file. Inside network error, under missing config, case, URL, build, failed. After adding URL build failed, we'll see an error because any switch statement handling network error now requires this new case. Click on the error, fix. The code for our .url build failed can simply return failed to build URL. With our new case added, we can go back to data fetcher, add guard in front of lat to safely unwrap our URL. At the end of the parentheses, else with braces. Inside the braces, type throw network error dot URL build failed. This ensures that if our optional URL is nil, we throw our new case, preventing potential issues down the line. We can finally start parsing this response. Make some space after our print statement. Let parenthesis data, comma URL response, parentheses equals, try, awaits, URLSession dot shared dot data from, fetchTitles URL. Let's break this code down. This function returns two values, data, which is the actual raw JSON data from the API, and URL response, a URL response object that contains metadata about the request. This could include an HTTP status code, which tells us whether the request was successful or not. These values are assigned to the variables data and URL response, respectively. Try is needed because this function can throw an error. For example, if the network is down. Await means this is an asynchronous operation, so the function completes in a separate thread without blocking the app. URLSession is a built-in class in Swift that handles network requests. .shared is a singleton instance of URLSession, meaning we don't have to create a new session manually. Finally, .data from fetchTitles URL makes a network request to the URL we built earlier. It downloads the data from the API and also gets a response from the server. Next, we need to check if the URL response is valid. I'll scroll down and hit enter a couple times. Guard let response equals URL response as question mark HTTP URL response, comma, response dot status code double equals 200, else, braces. We first check if the URL response above is a valid HTTP response. If it is, the HTTP URL response is assigned to response. Then we check whether our response variable has a status code of 200. A 200 status code means that everything went well and the request was successful. If either of these checks fail, we can throw network error dot bad URL response underlying error any error. Since we don't have an existing error to pass, we need to create our own using NSError. NSError stands for next step error, an Objective-C class used to represent errors in Apple's framework. Select the NSError that includes domain, code, and user info. We can put domain, code, and user info on their own line to avoid clutter. Domain represents where the error is coming from. In this case, parentheses data fetcher, works because the error comes from this function. Code is the status code from the URL response. We can attempt to get this code using parentheses URL response as HTTP URL response parentheses dot status code -1. If a status code exists, we use it. If there is no status code found, we default it to -1, indicating an unknown issue. User info is a dictionary containing additional error details, such as a descriptive error message. We can use brackets and s localized description key, quotes, invalid HTTP response. This ensures that if the response is invalid, we throw a readable error that helps identify the issue. I'll scroll down for more room. We check to make sure the response was valid. Now we can define our decoder. Click outside the guard statement. Let decoder equals JSON decoder. A quick note. Our variable poster path follows camel case, meaning the second word starts with a capital letter. In the API, they use snake case, meaning words are separated by an underscore, like poster _ path. To account for this difference, we can add decoder dot key decoding strategy equals dot convert from snake case. This tells the decoder to automatically convert snake case keys from the API to camel case. Finally, we can complete the parsing. Type return try decoder dot decode API object dot self tab from data parentheses dot results escape. Since decoding can fail, we need to use try in case an error is thrown. The decode function takes an object type and tries to convert the raw URL data into that object. In this case, we're decoding the data as our API object struct. Remember that API object contains an array called results. This results array is made up of multiple title structs, where each struct represents an individual movie or show with its properties. By returning results, we get a fully decoded array of titles that we can now use in our app. I know this was a lot to take in, and some parts might have been a bit confusing. Feel free to rewind and revisit any explanation if you need to. Also, if you have any questions, don't hesitate to ask. I'll do my best to help. You're doing an amazing job, and the fact that you made it this far speaks volume about your dedication. That's it for this lesson. Thank you so much. I can't wait to see you in the next one.